Okay, this is lesson 2.9, rationalizing radical expressions. And along with rationalizing the expression, what we're also going to do is do a couple of examples of adding and subtracting with some expanding built in there too. So really the second part of the lesson is the rationalizing. And we'll talk about what rationalizing means. But first let's do some adding and subtracting. When you're adding and subtracting radicals, you can add and subtract them if they have the same radical. For example, 2 root 3 and root 3 are like terms. They have the same radical. And the way you add them is the same way you add variable expressions. Like if we had 2x and x, you would add them together and get 3x. If we have 2 root 3 and root 3, we could add those together and get 3 root 3. And the way you add them is you keep the radical the same and you just add the coefficients in front. So if we look at our first expression here, we don't have any radicals that have the same, any terms that have the same radical. But if we simplify each of these to the simplest radical, maybe we'll have some things in common. So let's try that. Root 12 can be broken down into two factors, 4 and 3, and 4 is a perfect square. So if I break this to root 4, root 3, I'm going to do two steps here at once. Now we don't have to show this middle step every time, but I'm going to show it for this example. The square root of 4 is 2 root 3. If we break down 18, we can break it down into 9 and 2. So root 9, root 2, and if you square root 9, you get 3. Now if you practice and write the perfect square term first, you always end up with your coefficient in front, which is very helpful. For 27, you can break that down into 9 and 3. So subtract root 9 root 3, and the square root of 9 again is 3. So we have 3 root 3. And 8 can be broken down into the factors 4 and 2. So root 4, root 2, which is 2 root 2. And now we have a couple like terms. I'm going to highlight my first pair. 2 root 3 and minus 3 root 3 are like terms because they have the same root. So the way we put them together is we add or subtract the coefficients. 2 minus 3 is negative 1 root 3. And if I look at my other pair, I've got 3 root 2 and 2 root 2, and we're adding because the term in the middle is adding, or the sign in the middle is adding. So we got 3 plus 2, which is 5 root 2. And there we have a fully simplified radical expression. These aren't like terms because they have different radicals, so we can't put them together. Example B, I'll leave for you to try. Now expanding is done the same way as if you were expanding something that didn't have radicals and just had variables, except you can actually simplify the radicals. We're just multiplying, and we did multiplying in the last video. If you have 3 root 2 in front of a bracket which has two terms inside, you have to use the distributive property. So we would do 3 root 2 times 2 root 6 and 3 root 2 times root 10. And if I show both of those multiplications, you don't have to show this step, I'm going to show it anyways. We've got 3 root 2 times 2 root 6 plus 3 root 2 times root 10. We get two different multiplications. 3 root 2 times 2 root 6 is the first one. 3 root 2 times root 10 is the second one. How do you multiply radicals? You multiply the coefficients, and then you multiply the radicals. 3 and 2 is 6. 2 and 6 is 12. 2 and 6 are under the roots, so they go under the root in the answer. Next one, 3 root 2 times root 10. 3 times 1 is the coefficient, is 3, and 2 times 10 is 20. And now we simplify our radicals. 12 can be broken down into 4 and 3. So we get 6 root 4 root 3 plus 3 times root 20. 20 can be broken down into 4 and 5. So we got 3 root 4 root 5. Now actually take the roots. We got 6, root 2 is 2. Sorry, root 4 is 2. Root 3. And root 4 is 2 again, so 3 times 2, root 5. And now we can actually multiply those coefficients. 6 times 2 is 12. We got root 3. And 3 times 2 is 6. root 5. And if those were the same radical, we could add them, but they're not, so we keep them separate. Now, I showed a lot of extra steps here that you don't necessarily have to show. You do not have to show the multiplication step, and you do not have to show these two steps. You could very well do this in 2 lines, which would have been this line and this line. Okay? But as you work through these examples, you'll get more and more efficient. I'm going to leave B for you to try. The difference between A and B is this one's got 2 terms by 2 terms, so you're actually going to have to FOIL. So I'll show you the multiplications. It would be 3 root 2 times 4 root 2, 3 root 2 times negative 3 root 5, 4 root 5 times 4 root 2, and 4 root 5 times negative 3 root 5. There's going to be 4 steps. And at the very end, you're going to end up with 2 terms. Let's see if you can get there. You can pause the video, try it now, or you can wait till the end of the video and give it a shot then. Okay, that's it for adding and subtracting, expanding. Let's try rationalizing. What does rationalizing mean? Well, in the very first video I said when you're simplifying a radical, you can't have a radical in the denominator. So rationalizing is something we can do to get rid of a radical in the denominator. Rational expressions are simplified when the denominator does not contain a radical. So, to get rid of the radical in the denominator, we can multiply the numerator and denominator by a term or expression that will remove the radical. If there's one term in the denominator, you multiply top and bottom by the radical. If the denominator has 2 or more terms, you multiply the top and bottom by something called the conjugate. And conjugate is a binomial formed by negating the second term, which sounds confusing. But, for example, say we had x minus y. The conjugate would be x plus y, because negating negative y would give you positive y. It's basically the same terms with the opposite sign. So when you factor a difference of squares, the 2 factors are conjugates. They'll be the same terms with the opposite sign. And I'm going to show you 2 examples. 3 examples. No, I'm going to show you 2 examples. First example, 1 over 3 root 2. There's only one term in the denominator, 3 root 2. How you can tell if there's multiple terms is if there's addition or subtraction between them. This one has 2 terms. This last one also has 2 terms. So how do we simplify if there's one term? Well, if there's one term, multiply top and bottom by the radical. The radical that's in the denominator is root 2. So to simplify this, we're going to multiply the top and bottom by root 2. And I'll show you what happens. On the top, 1 times root 2 is just root 2. On the bottom, 3 root 2 times root 2. Multiply the coefficients. 3 times 1 is 3. Multiply the roots. Root 2 and root 2 is root 4. What's the square root of 4? 2. So it's 3 times 2, and 3 times 2 is 6. Root 2 over 6. Now, in terms of what steps are essential, when you multiply root 2 by itself, basically the answer is just 2. The roots go away. Anytime you multiply a radical by itself, root 2 and root 2, the answer will just be whatever the radicand is, in this case 2. If you multiply root 3 and root 3, the answer is 3. If you multiply root 102 by root 102, the answer is 102. Once you recognize that pattern, you don't have to write root 4. You can just go right to writing 2 as the answer. And 3 times 2 is 6. And this is a fully simplified radical. And again, if you have a calculator that allows you to type in radicals, if you type this one in as a fraction, 1 over 3 root 2, you get root 2 over 6. That's this simplified form, because you can't have a radical in the denominator. Well, you can, it's just not simplified. B, if there are 2 terms, the way you simplify is you multiply by the conjugate. And I'm going to show you what I mean. Well, the conjugate of 2 root 6 minus root 3 would be the same 2 terms, 2 root 6 and root 3. with the opposite sign, plus. And we have to multiply on top and bottom. So the top's going to get a little messy here. 5 times 2 root 6, we multiply the coefficients, and we get 10 root 6. This is 2 terms, so I better put it in brackets here and show you that with FOIL, 5 times 2 root 6 and 5 times root 3, which would be 5 root 3. Now the denominator is where it gets a little interesting. Multiplying by the conjugate, this looks like factored form of a difference of squares. And we know when we have a difference of squares, we're going to end up with 2 terms, and they're both going to be perfect squares. And if you have something that's a perfect square, it's going to be very advantageous to us if we're working with roots because it's going to eliminate our roots. And I'm going to show you how. Okay? I'm actually going to FOIL this out, but eventually we'll get a little bit more efficient with this. We won't have to do the FOIL because you'll recognize a pattern, and I'll point it out for you. But here we go, we're going to FOIL. 2 root 6 times 2 root 6 would give us 4 root 36. Notice that root is a perfect square. 2 root 6 times root 3 would give us 2 root 6 times 3 is 18. Now this one is not a perfect square, but watch what happens because we multiplied by the conjugate. Negative root 3 times 2 root 6 will give us negative 2 root 18. We get the exact same term with the opposite sign. These 2 terms are going to add to 0. And it's going to eliminate those middle terms, and it's just going to leave us with the first term. And our last term, which will be negative root 3 times root 3, is negative root 9. A perfect square. So, if we simplify this, the top is 10 root 6 plus 5 root 3. And the bottom will have 4 root 36. I'm going to square root 36. Square root of 36 is 6. I'm going to simplify this all in one step here. 6 times 4, 24. 2 root 18 minus 2 root 18 is 0. Square root of 9, 3. So we got 24 minus 3 on the bottom. Look at that, no roots. And if we subtract, we get 21 on the bottom. Now the top has something in common. The top has 5 common to both terms, so we can common factor a 5. And if we're going to common factor fully, we can actually common factor root 3 as well, because 6 can divide by 3. And what we're left with inside is 2 root 2 and 1. And now we have a fully factored and simplified expression. Now, factoring here didn't actually give us anything that we could divide away, so the factoring step is not necessary. This could be a final answer for a numerator because we can't simplify any further. Okay? But the denominator, we would have to do the subtraction and get 21. All right, I'll leave C for you to try on your own. We have 2 terms in the denominator, so we're going to multiply by the conjugate. Okay? Remember, the conjugate will be these same 2 terms with opposite sign. See if you can come up with the right answer. Check your answer on the course website. That's it for lesson 2.9, and that's it for Unit 2. Thanks for watching, and I'll see you next time.